and the fact that we're going to deal with composite solids. So composite solids are objects that are composed of two or more three-dimensional solids. So what's going to happen is, get off of that. What's going to happen is that we are going to have multiple shapes. So on every other problem, it was just a sphere, or it was just a cylinder, or it was just a cone. Now we're going to have shapes like this one, where it's multiple shapes put together. Okay. So what shapes do you see on that first one? I see a cylinder and I see a cone. Very good. Now, are the cylinder and cone, when you put them together, are they going to have a larger volume when you started or a smaller? Larger, because you're making a bigger shape, right? You're putting them together. So first, can we remember what the formula is for a cylinder? Do you remember, Courtney? Change your mind? Liana, you want to help her? Do you remember? There's no 4, okay. Anybody? Oh, I think we got to practice our formulas here. Dr. Nelson, did you need me, or are you just popping in to say hello? All right. Oh, that's the cone. You're right. The divided by 3 is my cone. Don't forget your pi. Pi radius squared height divided by 3. Marilyn, do you remember the cylinder? You had your hand up and then I kind of... Very good. Pi radius squared. Don't forget your pi's. Your cones you're dividing by 3. Did it open for you? Okay. We do. Yep. So we're going to break it down that we have to find the cylinder, then we have to find the cone, and then we're going to add them together. So looking at just your cylinder, pi is a number. What's your radius? How do you know you have to divide it? You're right. Because it goes all the way across. Very good. That line is drawn all the way across, which is your, nicely done, diameter. So we have to divide that in half. So really my radius is 4. And what is the height of just the cylinder? 4. Height. Remember, between your two circles would be your 4. So we're going to type this into our calculator. Let's just finish all of this cylinder all at once. What are you going to type in? 4 squared, which is 16. Then what are you going to type? Answer times 4.
Answer times
Very good. 4 squared, answer. You have to, though. That's what you're using. He thinks it's too many buttons. But you're not going to get to use your phone. And I've told you that. When it comes to state testing, this is all you get, and we can't help you during state testing. I think if you ask the rest of your classmates, it's not that hard. Courtney, what'd you get? Ooh, did she round correctly? Is it supposed to be 0.1? Yes? Okay. All right, let's go to our cone. Pi radius squared height. Pi is a number. What's my radius of the cone?
4.
Why?
It's the same as the top.
Very good. There's not really anything that's labeled for my radius of my cone, except for it shows that my cone is the same circle as my cylinder, right? Which means it's going to have the same radius, which we said was 4. How tall is my cone? 5. And then we can't forget to divide by 3. So in your calculator, 4 squared, answer times 5, answer times pi, answer divided by 3. Liana, what'd you get? 83.8? Anybody else get 83.8? Bless you. Yes? Rounding is good with 83.8? Okay, last step. Now on your calculator type 201.1 plus 83.8. Say it again. 284.9. And what would my label be? Feet cubed. Always cubed. Always cubed. Questions on that one? Many of you have already moved on to the next one. Why do you add it? Because you put those two shapes together to get a bigger shape. Okay, we're going to talk about that actually on the next one. Tanya used cone-shaped beads to make jewelry. Each bead has a circular, that should say, hole through the middle. Find the volume of one bead. Round to the nearest tenth. What's different about this shape than the last one?
Inside.
It's inside. What does that mean? When that shape is inside, what does that really mean? Say it again. At all? I don't know what that means. I don't think we want to add them all. Think about a bead that's on jewelry. What do you know about it? What does it tell you it has? It's got a hole in it, right? So how is that different than the one before? We had to take away material, right? If it's got a hole in it, like on the last one, Jack and I just talked about, we add them together because the cylinder and the cone are being put together to make a larger object. And this one, because there's a hole in that, we're going to have to subtract that. Does that make sense? Okay, and I heard somebody say it right away. It's a cube, so we got to take our cube, and we have to subtract the hole, which is a cylinder. Now, a cube is also a rectangular prism, which is like a box. To calculate that, we are going to take length times width times height. What's so special about a cube?
The angles are all the same.
Not the angles, but the angles, yes, but the side lengths, right? All the sides measure the same. So what are the length, the width, and the height of that cube? 12. 12, 12, and 12. It only works that way because it's a cube. It doesn't always have to be that way. You might have three different numbers. So if we take 12 times 12 times 12, I get 12 times 12 times 12. 1,728. Okay. What's my formula for cylinder? Very good. Pi radius squared height. Now look at your cylinder. That's just the hole in the middle. This line goes all the way across. I'm going to tell you that. What's my radius? 1. My radius would be 1. And how tall is my cylinder? 12. It's as tall as that cube is. Nicely done. Okay, on your calculator. 1 squared. Answer times 12. Answer times pi. Anybody get an answer? 37.7. Haley, do you agree with that? Yeah? Rounded correctly? Okay. Now take 1,728 and minus 37.7. And we're subtracting because there's a hole. We're removing that material. What you got? Like that? What would my label be? Millimeters cubed. Good work, you guys. I'm super impressed right now. Right, because you like it, it's like drilled out. It's missing. Like if I had that in real life, it'd be missing. That's why you subtract it. Yep. No. How many times do I have to say it to you? No, it's not, because on your semester or on your Smarter Balance test, you have to use this calculator, and we cannot offer you help during that time. That's why we're using it. If you ask the rest of your classmates, they haven't complained about it once. I don't, and I'm tired of listening to it. Well, I'm tired of listening to it. On the next one, what shapes do you see? A sphere and a cylinder. Would we add those together or subtract them? Add them. They are making a shape that's larger. You only subtract if it's a whole. You only subtract if it's a whole. What is the formula for a sphere? This is the hard one, right? 4 pi radius cubed divided by 3. Nope. Why not divided by 2? The sphere is the whole thing. You only divide it if it's the top half. We're not dividing it. What's your cylinder formula?
Oh no, pi.
Very good. Okay, we're actually not going to calculate that one. I just want you to have those formulas written down. Okay? Let's go to the next one. What shapes do you have on this one? Say it again, Zayden. A half a sphere. We call it really a hemisphere, right? A half a sphere and a cone. Is that what I heard? Okay, this one, absolutely. You're going to take your sphere and divide it because it's a hemisphere, okay? So 4 pi radius cubed divided by 3, and then a big divided by 2. Do you want to finish that? Should we stick with the hemisphere for right now?
Yeah.
Okay.
The 17.
Very good. 7 goes all the way across with that line, so we have to divide it in half to give us 3.5. All right, on your own without any help from me, use your calculator to find the volume of that hemisphere. So you got to take 3.5 raised to the third. Answer times 4. Answer times pi. Answer divided by 3. Answer divided by 2. What do you get? 89.8? Yes? Everybody good with that? Okay, what's my cone? What's my formula for a cone? R squared H divided by 3. Okay? What's my radius of my cone? 3.5. 3.5, that's across the circle. What's the height of my cone? 5. And we'll divide by 3. Same thing. Put that into your calculator on your own. See what you get. What'd you get, Bryce? Anybody else get 64.2? No? 64.1? Better if it's a 1. Yes? Okay. Add them together. 89.8 plus 64.1. Courtney? Anybody else? 153.9? What's my label? Centimeters cubed. Centimeters cubed. Good work, you guys. I'm super impressed. Do this for me. Flip it to the back side because it's blank. Let's write your 3 formulas so you have them written down in one spot. Is that cool? Yeah. Okay, right here. Which one do you want first? Cone. What is a cone? Radius squared height divided by 3. Cylinder. What do you know about cylinder? It's the only one you don't divide by 3. And sphere is the really crazy one, right? Four pi radius cubed divided by 3. This way, you have all of those formulas on the back of that page. I'm going to give you your homework, and then we're going to go through. Some of these are hard to tell if the line is the diameter or the radius, okay? So we're going to go through every single one of these problems. So don't try to get started. Just put your name on this because you're going to need to know this information. Okay, ready? On number 1, 12 goes all the way across. I know it's hard to see on your guys' drawing or your copy. 12 goes all the way across. Number 2, 4 goes from the center to the edge. Good on those two? Okay. 3, 8 goes all the way across. Four, 11 goes all the way across. 5, the center to the edge of the hemisphere is 5. And then there's another chunk here that's another 5. Does that make sense? So from the center to the outside edge is how far? 10. So if you want to draw that here for yourself to remind yourself it's 10, I'm totally fine with that. Six you're going to cross off. 7. 2 goes from the center to the inside circle. And 2.7 goes from the center to the outside. Does that make sense? Okay. And 8 goes across on number 8. And 9 you're going to cross off. Now, another thing to help you, on my lesson plans, you can get the answer sheet so you can check as you go. Biggest thing we learned, this one won't be so hard. Put them in as you go. You get number 1 down, go put it in. You get number 2 down, go put it in. You only have to put 1 at a time. You might submit that form 700 times. That's okay. I don't care. All right, the rest of the hour is yours to work.